All right, ladies and gentlemen, this is your review for test number 1, Fall 2020 College Algebra. When is this test going to be? It is going to be Friday, September 25th in the morning. I'll probably post it before 8 o'clock. Anytime then through Sunday, the 27th, at midnight, basically. We'll say 11:55 p.m. All right. You may choose to do your test anytime during that basically almost 72-hour period. How many minutes? Are you going to have 120 minutes, 2 hours? And it is uninterrupted. In other words, when you start, you have 2 hours to finish. You may not take a break. You may not pause. The 120 minutes counts. So once you start, you have 120 uninterrupted minutes to finish. What to have with you, I would highly suggest you have your scientific calculator. I would highly suggest you have your notes. And remember, all your notes will be on Module 1 of Blackboard. I suggest you copy these notes and have them handy for reference. Also, I would suggest that you have the review copied. I'm going to work problems, and I'm going to have these put on your Module 1 for Blackboard. I would suggest especially that you have your test number 1 review copied and handy. How many questions? There are going to be 15 questions. They will have multiple parts, so don't be surprised if, for instance, question number 3 has 2 parts or question number 7 has 3 parts. 15 questions, though, but they will have parts. Now, if you are familiar with these 15 questions on the review, you'll be very, 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 that's 3 varies, familiar with the 15 questions on test number 1. Got that? So get familiar with the 15 questions on the review. You will be very happy that you did, because you'll find that the 15 questions on the test are very similar. All right, let's begin and start looking at the questions, the types of questions you will see on your test. Number 1, solve the absolute value equation. You'll be given an equation that has an absolute value in it. Let me give you some steps to deal with an absolute value equation. Step number 1. Isolate the absolute value. That means get it by itself. So to do that, I'm going to add 6 to both sides, and I get absolute value equals 6. Now, your second step is the one that's going to require some knowledge of absolute value. If I have an absolute value in an equation, I may re-express it as 2 non-absolute value equations. And here's how I do that. I simply take what's in the absolute value and set it equal to the number, or I take what's in the absolute value and set it equal to its opposite. 2 equations to solve. All right, and I'm going to solve them in the same way. I'm going to get the y by itself. So minus 5 minus 5 And I get 2y equals 1, or these cancel, right? 2y equals negative 11. Divide both sides by 2. And I get y is 1/2, or y is negative 11/2. So these are my two solutions. Solve the absolute value equation. We did, and there it is. And my two solutions are positive 1/2, negative 11/2. All right, these steps. Isolate the absolute value, re-express as two non-absolute value equations, and solve them. All right, keep this in mind because you may run into an instance like this. Should I have something like 2y plus 5 plus 6 equals 0? If I have something like this to solve, and I take my first step, isolate the absolute value, and I should get a statement like this. Please note, this is a very exceptional statement. The absolute value equals a negative number. Seems like I remember that an absolute value will never be negative. Is that correct? That's correct. Absolute value will always be 0 or positive. Absolute value is never negative. Since this is an impossible statement, since absolute value is never negative, a solution set here is no solution. If you should ever get an absolute value equals a negative number, no solution. Keep that in mind. All right, problem number 1. Another solution here. Solve the following linear equation. Notice the speciality of this equation. I got me some fractions. All right, here's the steps. Step 1. Find the least common multiple of your denominators. Another way to think of it is, what would be the common denominator? Hey, now notice these denominators are the same. If I had different denominators, like a 2 and a 3, then the LCM would be 6, right? The smallest number, the least number that both 2 and 3 would divide into would be 6. But since I just have one denominator, find the LCM of your denominators, that's 7. Step number 2, now our point in doing these steps is to get rid of the fractions. We would rather deal with an equation without fractions. So my second step is to multiply all parts by the LCM, which happens to be 7. So I'm going to multiply this, this, and this by 7. And since these have fractions involved, I'm going to put the 7 over 1 7 over 1, so I can remind myself that my 7s are going to cancel. Every part, fraction or not, is multiplied by 7. Now don't multiply, go ahead and let your denominators cancel. So here we go, cancel, 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 cancel. So I have 2 times w minus 1 minus 27 equals negative 28. That's where we want to be after we do this step. We don't want any fractions. All right, obviously a little distributive. Got some like terms to get together. Obviously, I'm trying to get the W's by themselves. So let's get rid of this 29. That's 1. Divide by 2, and I got my answer. Hey, there's another answer of 1/2. They must have had a special at Walmart or something. Solve the following linear equation. We did. W is 1/2. Again, if you have an equation with fractions, check out your denominators. Find the LCM of your denominators. Step 2, multiply all parts by that LCM. That should give you an expression without fractions that you should be able to fairly easily solve. All right. Got us some formulas like the circumference equals 2 times pi times the radius. A very familiar formula. It says solve the indicated formula for the indicated value. And we're supposed to solve this guy for r. If I solve something for r, it should look like this. R equals, right? That's what we mean by solve for r. Get the r by itself. So right now, r is being multiplied by 2 and by pi. The way we undo a multiplication is division. So we're going to divide both sides by the 2 and the pi. Why? Because that will cancel and we get r by itself. So we get r is c over 2 pi. That's pretty easy, huh? So we have solved it for r because the r is by itself. All right. Here's a word problem. Find 3 consecutive integers whose sum is 444. All right, there's multiple ways you can do this. Some of you might have used the technique where you have an n plus 1, an n plus 2, and so forth. Here's a way I think of it. It's kind of the strong arm yeoman's way to do this. I have 3 consecutive integers. That's consecutive means in a row, right? 19, 20, 21, 48, 49, 50. Consecutive integers. I want to find 3 consecutive integers whose sum is 444. What I'm going to do is realize that the average of these 3 numbers is the middle number. The average of any 3 numbers is the middle number. You add the 3 up and divide by 3, you're going to get the middle number. So the average is going to be this guy right here. How do you get an average of 3 things? Well, you add them up. We already have. We added them up and got 444. You add them up and divide by 3. So if I divide this sum by 3, I am going to get the average, which is my middle number. This is why you have your scientific calculator handy. 444 divide 3 is 148. So I got my middle number, 148. And that tells me fairly easily what the next higher number and the next lower number are going to be, 149 and 147. Hey, that's pretty easy, huh? Obviously, we have 3 consecutive integers this time, so we divided by 3. If you had 5 consecutive integers, you're going to divide by 5. That'll also give you the middle number. Here's the one thing that we haven't addressed here. What if I don't have an odd number of numbers, which gives me a middle number? What if I have an even number, like 4 numbers? I don't have a middle number. Well, if I find the average, I'm going to be finding the number in between my 2 middle numbers. Let's say our average is 48.5. Well, that tells me that the next higher number is 49, and the next higher is 50. The next lower number below 48.5 is 48 and 47. 47, 48, 49, 50. Consecutive integers. So if I have a consecutive integer problem, I'm going to divide my sum, my total, by however many numbers I have. That will give me my middle number. If I have an even number of numbers, it will give me the middle number, but that will be in between my two integers. Remember, integers are whole numbers, positive or negative. Integers are whole numbers. So 48.5 in between my two middle numbers, I can easily figure what the numbers are going to be. So you'll have one consecutive integer problem. All right, consider the compound inequality. Compound inequality looks like this. It's basically two statements. Something is less than something. Something is less than something. It's two things put together, hence we call it a compound inequality statement. My first part is to solve it and express in interval notation. So let's solve this guy. Now to solve an equation, we get the variable by itself. Likewise, to solve an inequality, we get the variable by itself. The variable will be in your middle part. First, second, and third part. The second part, the middle part, is where you're going to find the variable. So this is where you're going to focus to get the x's by themselves. You're going to approach this just like you would an equation. How would you get the x by itself? I think I need to get rid of that minus 2. So I get rid of a minus 2 by doing the opposite. But I don't do it just to 2 parts. I do it to all 3 parts. We are getting the x, the middle part, simpler and simpler. That's 45. That's negative 20. And by the way, if you have difficulty adding positive and negative numbers, use your calculator. Let your calculator help you. All right, same thing. Get the x by itself, divide by 5. So I get x in the middle. This is 9. This is negative 4. So x is somewhere in between negative 4 and positive 9, but please note the difference in my inequality symbols. This means that x could equal 9. This means that x could not equal negative 4. It has to be greater than negative 4. So another way to think of it is x is in between negative 4 and 9, and also including 9. Now they asked me to put this in interval notation. Here's what that looks like. This is where I use the parentheses and bracket combination. Your interval notation is going to look like one of these guys based on what your inequality symbols are. Remember, just less than or greater than is going to give me parentheses. Less than or equal to or greater than or equal to, I'm going to think about brackets. Okay? So this guy's got an equal to sign, it's going to have a bracket. This guy doesn't have an equal to sign, it's going to have parentheses. And here's how an interval notation looks. X is somewhere in between negative 4 and 9. And my ending symbols are going to be a bracket with the 9 because of that equal to sign, a parentheses with a negative 4 because no equal to sign. So this is the interval notation. And as I look at this, I'm thinking x is anything in between negative 4 and 9, but negative 4 is not included 9 is included in my solution set. All right, this is a picture of our number line graph. So let's graph the solution set on the number line. I need my two important points, -4 and 9, and you're going to use your graphing techniques from Hawks, where you take in this case, I'm going to take a parentheses and put it right here at -4 because it's a -4 here. I'm going to take a bracket and put it at +9 because +9 is there. So a bracket at 9, I'm going to use my Hawks techniques to put the bracket right there. Then I'm going to select a parentheses and put it here at -4. And then I'm going to fill in everything in between. So you're going to use your graphing techniques from Hawks to indicate that. This is the same as that. This is the number line graph. This is the interval notation. All right. Number 6, consider the following points. There they are, -2, 8, -2, -8, 1, 1. Find the distance between the two. You're going to be asked to find the distance between 2 points, which means you need to have handy your distance formula, which is y2 minus y1 squared plus x2 minus x1 squared. This is why you're going to want to have these notes handy, so you can have the formula handy. All right, what's a x2 and a y2 and a y1 and what is all that? Well, it means I'm going to label my 2 points. I'm going to call one of them, it doesn't matter which one, I'm going to call one of them x1, y1. I'm going to call one of them x2, y2. All that means is the first point xy and the second point xy. And then I'm going to fill in these various numeric values for these y's and x's in my formula. Keep in mind it's a square root. So y2 minus y1, that's 1 minus a -8. Don't lose that negative. Y1 is already negative, so make sure you include it as negative. And then I have x2 minus x1. That's x2 is 1 minus -2 squared. All right, let's see what we get. 1 minus a -8 is 1 plus 8 squared. 1 minus -2 is 1 plus 2 squared. That's 9 squared. That's 3 squared. That's 81. That's 3. Here's 9. I get square root of 90. Now, here's one thing that you're going to need to be able to do to simplify your radical, your square root. How do I know if this is simplified or not? Well, I don't yet until I break square root of 90 down into its parts. So number 1, I want to use the old factor tree concept to express as prime factors. Factors are things that are multiplied. So let's see, what'll go into 90? And you can do any 2 numbers that'll go into 90. Well, let's say 9 and 10, that's obvious. Now, I stop whenever these numbers are prime. They're not, so I'm going to keep going. 9 is 3 times 3. Those are both prime, I can stop. 10 is 2 times 5. Those are both prime, so I can stop. So first I'm going to express as prime factors. So 90 expressed as prime factors is 3 times 3 times 2 times 5. Now here's how you simplify the radical. If something shows up twice, and we're thinking twice because this is a square root, right? Shows up twice, bring it out once. Bring it out of the radical once. So 3's show up as a factor twice, bring them out once. So 3 is now on the outside of the radical. All that's left inside the radical is 2 times 5. That's 10. So sometimes, and this is an instance, your square root will simplify. Use this step to these two steps to simplify it. Express it as prime factors. That's using the old factor tree concept. Once you have it as prime factor, hey, if this was 3 times 7 times 2 times 5, nothing showed up twice, so it will be simplified. But if something does show up twice, bring it out once. All right, so we found the distance between the two. There it is, 3 squared roots of 10. Secondly, find the midpoint of the line segment joining the 2 points. This is my second formula. I got a distance formula and I got a midpoint formula. The midpoint is almost insulting. It's so simple. Midpoint is a point, so it's going to have an x and a y, right? And to find my x coordinate for the midpoint, I just average my x's. It's just x1 plus x2 over 2. That's how you average two things, right? Add them together, divide by 2. Likewise, my y-coordinate, average the y's. Add them together, divide by 2. Hey, that's easy. So let's see, x1 plus x2. It's going to be 1 plus negative 2 over 2. The y's are going to be 1 plus negative 8 over 2. So that's negative 1 over 2. That's negative 7 over 2. And that's it. Let's see. It didn't tell me anything how to express my answer. So negative 1/2, comma, negative 7/2 is my midpoint. Again, this is your midpoint formula. This is your distance formula. Have those guys handy because you'll be asked to find the distance and the midpoint. All right, number 7. Determine if the following equation is linear. If it is, put it in standard form, x's plus y's equal a number. So to determine if an equation is linear, answer this question. Does it just have x's, y's, and numbers? If it does, it's a linear equation. Hey, the problem comes up if it has x squared or for xy, something like that, or square root of y, something. These are all indications that it's not linear. But if I just have x's, y's, and numbers, I got myself a linear equation. So we're going to simplify this guy and see if we just get x's, y's, and numbers. A little distributive first. Got me some like terms here. Negative 1x plus 7x is 6x. two questions. First of all, is it linear? Yes, it is. Just has x's, y's, and numbers. Put it in standard form. X's plus y's equal numbers. We just did. If you had it backwards, like if you had the 7y plus 6x, you're just going to switch them around. Put the x's first, the y's, and then the number. That's standard form right there. All right. Consider the following equation. I'm considering it. Find the x and the y-intercepts, if possible. Now here's where you need to remember how to find an x-intercept. To find an x-intercept, you let y equal 0 and solve for x. Every single time. To find an x-intercept, you let y equal 0 and solve for x. So in this equation, I'm going to let y equal 0. So instead of 5y, I have 5 times 0 minus 6x equals 30. See what we did? We let y equal 0. That's just 0. I get negative 6x equal 30. I'm going to divide both sides by negative 6. And I get x is negative 5. That's my x-intercept. Find the x-intercept, I just did, negative 5. Another way to say this is it's the point x, y. The x-intercept always has a y that's 0. So there's my x-intercept right there. All right, similarly, to find a y-intercept, you let, what do you think? That's right, x equals 0 and solve for y. All right, so I'm gonna, in this equation, I'm gonna let x equal 0. So instead of 5y minus 6x, I got 5y minus 6 times 0. Once again, that's 0. Divide both sides by 5. X is 6. That's a y. Sorry. Y is 6. So I let the x equal 0, solve for y, y is 6. And you can say the y-intercept is 6, or you could say, if they say express it as an ordered pair, you'd say, let's see, the x was 0, and the y is 6. So again, a y-intercept always has an x value that's 0. An x-intercept always has a y value that's 0. So I found my x and y-intercepts. All right, it says graph the equation by plotting the x and the y-intercept. All right, so I'm going to plot the 2 points, negative 5, 0. Yep, negative 5, 0. And the point 0, 6. And again, on your Hawk's approach, you're going to put a point there, you're going to put a point there, and then you're going to connect the two. And there's my line. Graph the equation, got it. X-intercept, where it intersects the x-axis. Y-intercept, where it intersects the y-axis. Connect the two. All right. Consider the following equation. Find the x and y-intercepts if possible. Hey, notice something's different here. Notice I don't have an x in this equation. Does that ring a bell? Now let's look at the last equation, the one we just did. If I have x's and y's in my equation, which I do here, I'm going to have myself a slanted line like this. And it's going to intersect both the y-axis and the x-axis. So if I have x's and y's in my equation, I have a slanted line, and I have both x and y-intercept. Hey, but what if I just have y's in my equation? In other words, 8y equals 56, 14y equals 3, negative 2.8 y's, negative 2.8 y equals negative 34. If you just have y's in your equation, this tells me that I have a horizontal line. This is in your notes, by the way, that I have a horizontal line. Hey, so it's a horizontal line, which means it's only going to intersect the what? It's only going to intersect the y-axis. It's only going to have a y-intercept. Horizontal lines will only cut the y-axis. Hey, what if I just have x's in my equation, like 15x equals 70? If I just have x's in my equation, I'm going to have myself a vertical line. And think about it. A vertical line will only cut the x-axis, so it's only going to have an x-intercept. All right, so let's keep that in mind here. This guy only has y's in it, so this is going to be pretty doggone easy to solve for y. 8y equals 56, divided by 8, y 7. So I have me immediately my y-intercept, 0, 7. And what I'm going to observe here is that since this guy is a horizontal line, it's not going to have an x-intercept. So my y-intercept is right here. And since this is a horizontal line, it has no x-intercept. All right, let's graph the equation by plotting the x and y-intercepts. Yeah, but I don't have an x-intercept. If an intercept does not exist, use another point to plot the graph. All right, so I got one point here, my y-intercept. It's 0, 7. Now look at this equation right here. This is the simplified form of my original equation. It says y equals 7. All I have to keep in mind is, for my next point, use another point. For my other point, all I have to keep in mind is y is 7. So whatever this point is, y is 7. So I've already got 0, 7, so I can't use that one. So let's use, I don't know, here, 5, 7. 5, 7. Notice how it makes a wonderful horizontal line. Or 23, 7. 23, 7. Or negative 3, 7. Just so long as you have a y that's 7, and you're going to have to give a point, like 5, 7, then I've got myself the horizontal line. This is the horizontal line, y equals 7. So if you don't have one of your intercepts, use whatever you do have to find another point, in this case, where y is 7. Okay. Number 10, find the slope of the line determined by the following equation. Now you guys remember, hopefully, that if I put the equation of a line in this form, y equals mx plus b, the slope becomes wonderfully visible. In other words, if I solve an equation for y, the slope becomes visible. So I'm going to, this is called standard form, x's, y's, numbers. Standard form doesn't help me. I need to solve this equation for y. Once I solve it for y, my slope is going to be visible. It's the number in front of x. So let's solve this guy for y. I'm going to subtract 8x's from both sides to get my y's by themselves. I'm going to put my x's first because that's the way it's expressed. Everybody good there? I need y equals, not negative 6y, so I'm going to divide by negative 6. Now I got a negative over a negative, right? That's a positive. Positive over negative is a negative. Okay. One thing it's going to say is simplify. That's not simplified, is it? If you put 8 over 6 as your answer, I'm afraid you're going to have a frowny face after that one. So I got y equals, both divisible by 2. Remember, when I solve it for y, the number in front of x is my slope. So my slope is 4/3. By the way, do not put 1.333, the decimal form, because that is not exact. This is exact. 1.33 is an estimate. This is exact. So find the slope. All you're going to do, solve for y. The number in front of x is going to be your slope. Find the equation of the line in slope-intercept form that passes through a point and has a given slope. All right. So notice what you are given. You're given a point that your line passes through, and you're given its slope. Here's how we're going to approach this. We're going to look at the slope-intercept form of a line. That's important to know. Why are we going to do that? Well, because we have, I got 4 different variables. 1, 2, 3, 4. I know 3 to fill in for those. For instance, I know that the slope is -4, so this is my m right here. And look what else I know. I know a point, which means I know an x and a y. Oh my goodness. I know everything except b. So let's fill in the m, the x, and the y and solve for b. So here we go. Y, it's -6, equals the slope, -4, times the x, which is 0, plus b. That's 0, so I get -6 is b. Now I already know that slope is -4. And all I need in order to come up with the slope-intercept form of the line is the slope and b, the y-intercept. So I'm going to put these two guys together and have my answer. Y equals m times x plus b, plus a -6. I think I'll just write that minus 6. There you have it. Once again, how are we going to do it? We have a point, that's an x and a y. We have a slope, that's an m. We're going to fill in here, here, and here, and have everything except b. Now we got b. Once we have b, the y-intercept, and the slope, which was already given, we can fill that into our slope-intercept form. There it is, y equals negative 4x minus 6. All right. Consider the following equation. There it is, expressed in slope-intercept form, which means I need to solve for y, right? Because I need to express this as y equals mx plus b. So we're going to solve this guy for y. Here we go. I'm going to do a little distributive first. Negative 12 plus 3x. Negative times a negative is positive. I'm going to get my y's. I got to solve for y, right? So I'm going to get my y's all by themselves on the left side. So here we go, plus 14. That's 2 plus 3x. Now remember, I'm going to express this y equals so many x's plus a number. So I'm going to switch these two terms, just so I'll have the x's before the number. Divide by 7. And I've got it. Consider the following equation expressed in slope-intercept form. We just did. What this tells me is my y-intercept is the point 0.2. My slope is the fraction 3/7. So that's my slope. I'm going to use that to help me figure out this next part. It says find the equation of the line that passes through that point and is parallel to this line right here. It's parallel to this line. And here's what you need to remember. Parallel lines have what? That's right. The same slope. They have equal slopes. Parallel lines have the same slope. So my line is parallel to this line, so it must have exactly the same slope as this line, which is 3/7. So my slope is 3/7. So look what we got. We got a point, and we now have a slope, 3/7, which means I have exactly what I had in the last problem. A point, an x and a y, and a slope, m. And by the way, this problem could read, find the equation of the line that passes through that point and is perpendicular to that line. You remember this concept? Perpendicular lines have slopes. They're not opposites, have slopes that are negative reciprocals. So for instance, if my line has a slope of 3/7, the negative reciprocal of that is I flip it and change the sign. That would be my new slope if it said perpendicular to. Okay? So keep that in mind. So I have got a line that's parallel to this one, which means my slope is 3/7, the same as this one. And also I have a point negative 4/11. I'm sorry, negative 11/4. So I've got an x, I got a y, I got an m. I'm going to fill into y equals mx plus b. Just like in this last problem, we fill in for x, y, and m and solve for b. So let's see what goes on here. My y is 4. My slope is 3/7. My x is -11 plus b. This is going to get ugly. All right, so I get 4. Now remember, -11 is over 1, right? So it's -33/7 plus b. I got to get b by itself, so I'm going to add 33/7 to both sides. And I get b is 4 plus 33/7. That's ugly. One thing you probably want to do is change that to sevenths. 4 is the same as 28/7, right? 28 divided by 7 is 4. So b is 28/7 plus 33/7. b is 3 and 8 is 1. 61/7. Well, that's ugly. That's a Y-intercept that only a mother could love right there. But it's good enough because I have my slope. I have my Y-intercept. I'm going to put these two guys together and say y is the slope times x plus my Y-intercept. And there it is. Again, it's not pretty, but hopefully it's correct. All right, so parallel to, same slope. Perpendicular to, slopes that are negative reciprocals. Take the reciprocal, change the sign, you got your slope. Very similar to the one that preceded it. That's why I'm giving you these problems to have handy so you can make reference to them when you work on your test. Hey, consider the following relation. And by the way, they're talking about this little square right here. Determine the domain and range of the relation in interval notation. All right. When you have a graph, the domain of a graph is its width. And that's along the x-axis. So as I'm looking at this particular little square here, its width, how wide is it? Well, it's from here to here, right? This is the width right here. Now this is 1. And this is 0 here. That says -3 right there. So it's from, along the x-axis, it's from 0 to 1. That's how wide this is, from 0 to 1. The width is from 0 to 1. I'll look at the x-axis to consider the width along the x-axis. So from 0 to 1 is my domain. Here's a question. It's in interval notation, which means parentheses or brackets. Do I actually have a point at 0? Yes, I do. There it is right there. I have a point at 0, so I'm going to use a bracket there. Do I actually have a point at 1? Yes, I do. So I'm going to use a bracket there also. All right, since I have points at 0 and 1, I'm going to use brackets. That's the domain. Find the range. The range of a graph you're probably guessing this already, is its height along the y-axis. So here's my figure. The height of this thing is from here to here, right? From lowest point to highest point. It's from -4 all the way up to -3. And here's my question. This is my y-axis. Do I have a point at -4? Yes, I do. So I'm going to use brackets. Do I have a point at -3? I do. I'm going to use brackets. Determine the domain and range of the relation in interval notation. There it is. There's the domain, the width, there's the range, the height of the thing. Okay? Let me just give one more observation here before I go on. If I had a graph that looked like this, and I was asked to find the domain. Hey, the domain is the width of the thing. Hey, it goes infinitely that way, it goes infinitely that way. The width of the thing is from -infinity to +infinity. And that's how I express the domain, from -infinity to +infinity. And keep in mind, when I have -infinity or +infinity in an interval notation, I always have parentheses with them, because you never get to a point infinity, right? You don't include a point infinity. So there's the domain, the width of the thing from -infinity to +infinity. Likewise, the range. Hey, it goes infinitely low, it goes infinitely high. The height of the thing, again, from -infinity. And always put your smaller value first to +infinity. So should you have something like this, the domain is, the all real numbers domain is expressed as from -infinity to +infinity. That's extra. No charge for that one. All right, second part of the question, same question, dealing with this guy right here. Determine if the relation is a function. Now, how do you determine if a graph this is when you have a graph. To determine if a graph represents a function, you use the vertical line test. This is in your notes. Hopefully you're familiar with it. The vertical line test is this question. Will a vertical line cut this figure in more places than one? Yeah. If I draw a vertical line, it's going to cut it in more places than one. This guy fails the vertical line test. Since it fails the vertical line test, our conclusion is this is not a function. Got it? Not a function. Let's look at some other examples here. Let's say you have a circle. Will a circle ever be the representation of a function? No. Why? Because it's going to fail the vertical line test. No circle is a function. How about, let's do a parabola. Parabola going to be a function? Yeah. It passes the vertical line test. Every vertical line only cuts it one place, one place, one place, one place. No matter where you go, every vertical line will just cut it one place is a function. So if it passes the vertical line test, it is a function. If it fails the vertical line test, 2 points, not a function. This guy obviously failed the vertical line test. Determine if the relation is a function. It's not. Since it's not, give two ordered pairs 2 points as proof. So where are 2 points that a vertical line will cut? Now, be easy on yourself. Use a point that's obvious. Points that are obvious. So let's use these 2 points right here. Here are 2 points that are intersected by the same vertical line. They are the point 1, -3, and 1, -4. So if it's not a function, give 2 ordered pairs as proof. My 2 ordered pairs were 1, -3, and 1, -4. Hey, I could also have used 0, -3, and 0, 4, right? Because those 2 points, 0, -3, 0, -4, are also cut by the same vertical line. These are both good examples. But again, make it easy on yourself. Don't use any fractions or anything. All right, that's number 13. Getting close to the finish line, consider the following relation. X's, Y's. Rewrite as a function of X. How are we going to do that? Okay, let me give you some steps. Number 1, solve for Y. In other words, write Y equals something. That's what we mean by solve for Y. So we're going to solve this guy for Y. Which means I want the Y's on the left side and everything else on the right side. So I'm going to put this Y over here, get rid of a plus 2Y by doing the opposite. That's a 3x minus 3y equals -6. Some of you guys might do 2 steps at once. Good for you. I need to get, oops, that's 6x. I need to get the x's over here. Y is -9x. So I got -3y is -9x. I need to solve it for y. And again, a negative over negative is a positive. 3x. First step, solve for y, did it. Second step, express in function notation. So instead of saying y equals 3x, I'm going to call this a function. I'm going to say f of x equals 3x. That's it. These are the same, these are equivalent statements. This is just simply in 2 variable form. This is in function notation. Keep in mind, f of x and y are the same thing. So if you see something that says f of x equals 3x minus 2, you can rewrite that as y equals 3x minus 2. Same thing. Likewise, if you see something that says y equals 1/2 x minus 4, you could re-express that as function notation. It doesn't have to be f. It could be g of x, h of x, 1/2 x minus 4. Again, f of x is the same as y. Just different notations. All right, so we rewrote it as a function of x. There it is. Now I want to evaluate that function at x is negative 2. Remember, my function is f of x equals 3x. If I'm evaluating at a particular numerical value, I simply put negative 2 in this equation everywhere there's an x. Everywhere there's an x, I put a negative 2. So instead of writing f of x, I write f of negative 2, which is another way of saying the function evaluated at negative 2 is 3 times negative 2. Everywhere there's an x, I'm putting a negative 2. So f of negative 2, it turns out, is negative 6. Evaluate the function at x equal negative 2. There it is, negative 6. Determine the domain of the function. Express in interval notation. Now let's look at this guy, y equals 3x. Here's where I'm going to have to do a little bit of thinking based on some notes that we've already taken. Determine the domain of the function. One thing we just observed is that if I have an equation that has x's and y's, it is a slanted line. Now this is not going to be a picture of this line specifically, but it's a slanted line. All right? I'm not saying that it goes through those points, but it is a slanted line. It will look like this. So what is the domain of a slanted line? It's the width of the thing. It's as far left as you want to go to as far right as you want to go. It's negative infinity to infinity. Determine the domain of the function. All right, just another little aside is that you have some limitations on a domain, right? And I gave you a worksheet on this. I'm going to include that worksheet also with this. But it basically says there's only 2 limitations on the domain of a function. Number 1, if you have a value that results in a 0 denominator. And the implication of that is you got yourself a fraction. Can't have a denominator unless you have a fraction. The other limitation is a negative number under a square root. I can't have any value that makes a negative number under a square root. And the implication of that is you got yourself a radical expression. So if I have something like y equals 3x, another way to say that is f of x equals 3x. If I have a function like this, please look at it and note that I don't have a fraction. So I don't have to worry about the first limitation. And I don't have a radical. So I don't have to worry about the second limitation. If I have no fraction and no radical, I have no limitation on my domain. So my domain is negative infinity. It's all real numbers. Negative infinity to positive infinity. Now I'm going to give you the worksheet that goes along with this concept, so you'll have that handy. But in this case, I didn't have to worry about either a fraction or a radical. All right, last one is one of our maximum minimum problems. The total revenue for Jane's Vacation Rentals is given by the following function. And here's the function, where X is the number of rooms filled. This number X indicates the number of rooms filled. The revenue for, let's say, 50 rooms filled is 100 times 50 minus 0.25 times 50 squared. That's how we're going to find the revenue, the amount of money incoming for a particular number of rooms filled. Okay, here's the question. What number of rooms filled, what number of rooms filled produces the maximum revenue? All right. One thing to keep in mind is any kind of quadratic equation, that's an equation with an x squared, and let me rewrite this guy. Yeah, I'll do it like this. Minus b. I'm going to put the x squared first. You know that any function that is quadratic, that has an x squared, is going to graph into a parabola, right? Every single one of them. Parabola. And if I have a negative in front of my x squareds, I'm going to have a downward turning parabola. A negative x squared term is going to give me a downward turning parabola, which means I have a highest point. We call that a maximum. Likewise, if I have a positive x squared term, for instance, like r of x equals 7x squared minus 37x. Notice the x squared term is positive. That means I'm going to have an upward turning parabola, which means I'm going to have a lowest point called a minimum. Everybody got that okay? So if I have a quadratic function, and I do, and it has a negative x squared term, then it is a downward turning parabola. It has a maximum point. So this guy should have a maximum value. So let's look at it again. R of x all right. How am I going to find that x? I'm going to use a very simple formula that says this. X is minus b over 2a. What the heck does that mean? If I have a quadratic function, let me just give you a general quadratic function. Let's say it could be looked at like this. So many x squareds plus so many x's plus a constant number. Notice I don't have a constant number. It's plus 0, right? But I do have an a, so many x squareds, and I do have a b, so many x's. So if I want to find this special maximum or minimum x, I'm going to do the opposite of b over 2 times a. So let's do that. The opposite of b, that's my a. This is my b. So the opposite of b is negative 100 over 2 times a. A is negative 0.25. Everybody good there? And notice that's why I reversed these two numbers. I wanted the x squared term first, the a term before the b term, so I wouldn't make any mistakes. So a is the number in front of my x squareds, b is the number in front of my x. My x is going to be minus b over 2a. Here's where you'll be glad you got your scientific calculator. 0.25 times 2 is 0.5, but remember this is negative. Negative 0.5. Again, where you're going to be glad you have your calculator. 100 divide 0.5 gives me 200. And I got a negative over a negative, so it's positive 200. So what number of rooms filled produces the maximum revenue? Y, 200 rooms filled. How did we get it? We put it in the form, the regular standard quadratic form, x squareds, x's, numbers. And we did this right here. The maximum or the minimum, if you have a minimum question, it's going to be the same exact thing. The opposite of b minus b over 2a. And there you go. So I will upload all of this, including the notes on the limitations of a domain. And I would suggest that you run this off and have it handy, because your test is going to look a whole lot like this one right here. All right, good luck to you.